Got a fairly short video here. This is on the fuel system for the mixer. If you're not familiar with a mixer, I'm building a custom drum mixer that you'd see, a ready mix tank off of a tandem axle cement truck, and I mounted it on it's going to be a triple axle trailer that I've got its own little power plant here with a diesel motor. And this is going to be the fuel system for that motor. I've had everything running and functioning once already, but there were some problems, and as I kind of expected. So I had a feeling. I will get into that another time. This is about the fuel system. So there's a few little things with the fuel system. I thought I had some decent quality thread tape, and it wasn't holding up to the diesel. Now, for one, I know I probably didn't have the fittings tight enough. I'm not sure. I assume that probably would have helped. I noticed when I was pulling these fittings back out that all of the thread tape was just crumbling. So you can see here, I usually have a bottle of this natural gas pipe thread dope, thread sealant, and I was like, well, why don't I just use this? I know this stuff works. I was hoping it wouldn't react poorly with the diesel fuel, but I actually looked on the side of the can. It's good for gasoline, anything really. This is your one-stop shop. It'll do everything. So this is the best stuff to use. It's a little more pricey, but it's definitely worth it. So I'm pulling all of the fittings back out of the fuel tank, and I'm replacing them with this. You can see here, it just pretty much immediately I started noticing that it was sweating a little bit, and I was like, oh, it's probably not a big deal. It'll hydrate, and then it'll just quit leaking eventually. I'm going to give you a little bit of a tour of the fuel system, and then pretty much everything's going to be front-end loaded in this video. You can check the timestamps if you want to jump ahead. I'll just kind of give you a tour of the fuel system, and then the rest of the video is pretty much just the last 2/3 of the video is just going to be watching me change out all the fittings, and then maybe me just talking a little bit about what's going on with this unit. So you can see the throttle lever there. I'll talk about that in a sec. There's the fuel pump right there, and this was a 3-wire fuel pump, and then you can see the throttle cable that I've got kind of routed in there. You can see the fuel filter up there. I'll talk a little bit about the wiring in a second here. Right there you can see that's the return line on the top there, and I am going to put hose clamps on that. It's a low pressure. You know what I've noticed actually after working on the tractor and running it a little bit, after rebuilding that motor and running it and having a little bit of problem with the injectors, is there's very little, rarely ever any fuel that comes out of that return line. I don't know if that's different on different motors, or maybe if it's just circumstantial for some reason. But I mean, obviously it wouldn't be environmentally conforming to just not have that hose on there. But like if you really didn't want to deal with it, it's not really going to be that big of a deal. I've been running my tractor without the return lines on it just because, and I've been having the injectors on and off so many times. That's about all I'm going to say about that. So, and then you can see here we've got that is the feed line that I have the hose clamp on, and that's coming. I went with a gravity feed, and it wasn't for any other reason other than convenience. The tank was going up there anyways. I was like, it's high enough above the filter. As long as I keep a decent amount of fuel in it, there's probably always going to be enough head pressure supplying fuel. So I'm not really worried about it. It's not a big diesel motor. It's not sucking that much fuel. So I felt pretty confident about just going that route. It wouldn't have been that much more of an inconvenience if I would have had to put a fuel pump in this. But as you've probably seen there, I did just retrofit actually a hydraulic tank because it was really the easiest thing I could find. I tried looking all over for different options for fuel tanks, and there really wasn't anything that I was liking. I was trying to think maybe a boat fuel tank. You can see there the return line. You can see all this ridiculousness I've got going on here with all the step downs. I'm going to end up replacing these as well. I noticed a little bit of sweating on that fitting as well. I didn't fill this tank completely full when I tested it, when I was doing the testing with it, because, it's just, why would you? So even just a little bit of splashing around that this has done has already been hydrating these little bit of pipe tape here as well. So I'm pulling all these back apart too, and from now on, I'm just using, unless it's an airline, even then, I'm just using the pipe dope on everything. And the hydraulic tank here, it's kind of annoying that I can only tell my fuel level for the top half of the tank, but at least I can tell the fuel level for that much. What else was I really going to do? Like, I used an old jerry can, plastic jerry can for the fuel tank on the tractor, because that fuel tank went to crap on me. I don't really have time to build a custom tank. That might be something that happens eventually. So hydraulic tanks are really your best bet. They're just kind of annoying though, because as you've seen here, the highest you can put the return line is halfway up the side. And I checked on a couple other hydraulic tanks that I've got sitting around, and it's the same on all of them. The return line, none of the return lines go higher than halfway up the tank. So it would be nicer, just for, I don't know, it's probably not an issue if you had head pressure on your return line, but it would just be nicer, let's say that fuel line fails for some reason, then I don't end up draining out the whole tank just because of a bad fuel line. But it is what it is. I wasn't going to put a new hole in this tank just for that. Maybe we'll sometime down the road, but it's probably not going to happen. So anyways, it's got the vented cap on top, which is very nice. It's got a screen, fuel screen on the filler neck. So, hydraulic tanks are really your best bet, and they're fairly affordable. You get a baffle-less tank. They're even cheaper, like this is, and they're about the right size for a fuel tank. So it's other than, not knowing how much fuel you have when you have less than a half tank, they're a pretty good option. And then we'll hopefully have another look here at the, so you can see the little bit of a power plant from further back. And there is the fuel pump. So this is a 3-wire fuel pump. And what those 3 wires do, I think, so one of them is a ground. One wire is your constant power, and one wire is the energize the solenoid. So I'll show you in a second here when I function the ignition. And then you can see there's the throttle cable as well. And I just used cheap throttle cable from a garden supply place. So this is like a lawnmower throttle cable, which works fine. I want to upgrade that eventually, something a little bit sturdier, but it works fine for now. And then you can see my ignition system here. I've got everything running through relays. I've got that marked momentary and constant. So you can see me functioning it. It's got the auxiliary, which is unnecessary. I'm not using the auxiliary. That would be for a car ignition. You've got your key in on position. That's one wire that goes to the fuel pump. That will be your constant power supply. And then you've got the start position, the momentary, and that's the one that will energize the solenoid. So I'll kind of explain how that works. In the fuel pump, there's a solenoid that gets pushed forward that pushes an arm to open up the fuel valve to let the fuel flow. So the reason there's 2 wires for that is because it uses a high amount of energy to energize that piston, that solenoid, to push it forward. And then when you let off of the starter and just have the key sitting in the on position, it uses the signal from the constant power wire to just give it a small amount of energy just to keep that piston held forward. I think that explains it pretty clearly. So like I say, one is just on the start position and one is on the on position. And that's pretty much the fuel system. So this is just, the rest of this video is just going to be me changing out these fittings and replacing everything with pipe dope. And I'll just talk a little bit more about this mixer. We're going to do some more videos. Some of the other problems is what I'll talk about here. So one of the problems I ran into was a little bit of the fuel issue. Another, which I'm fixing right now. So this should fix a little bit of a leak that I had. Now I can fill the tank full and not have to worry about it. And another problem I had was, and this, I mean, I should have known better, but so I ended up putting the hydraulic filter on the suction side of the hydraulic tank. So I put the filter between the hydraulic tank and the hydraulic pump, which I thought, because it was an oversized filter, that it wasn't going to be that much of an issue, and it really shouldn't be an issue. But I ended up finding out that it does actually have enough restriction to maybe not necessarily cause cavitation. I think it was causing a slight bit of cavitation. But it was definitely reducing the flow on the system. So I moved the filter over to, actually we'll just rewind this and I'll just finish what I was talking about. I moved the filter over to the proper side of the hydraulic tank. I moved it back to the push side, the return side of the hydraulic tank. And then I ended up noticing, and I was running the mixer in this time, and everything was working perfectly fine. And I ended up, but the pump, it was cavitating. It was making a slight bit of a cavitation noise. And I couldn't tell if it was just because it was a gear pump and I was just working so close to it, or if it was because of cavitation. So I moved the filter to the proper location, and then I functioned it, and then I started getting a massive amount of foam coming out of the hydraulic tank. It was just foaming over like crazy. I was losing like a half a pail of hydraulic fluid each time I would try operating it. So what I figured was that restriction on the pump by having a filter on the wrong side was restricting the flow enough that it wasn't cavitating at the valve. But as soon as I moved the filter to the right side of the hydraulic tank and the pump was able to run at its peak performance, my underside directional control valve was all of a sudden the new cavitation point, and it was just sending a massive amount of foam to the hydraulic tank. So I was running, what was it? Number 8 function ports, which are, let's see, 8, 10, that's 1/2 inch, I believe, right? So obviously far, far too small for that gigantic motor. So I ordered, and to get a directional control valve that has 3/4 inch or number 12 function ports is extremely expensive. It's like $1,000 for your base. So I ended up buying a used one off eBay from the States. I bought a super old one. It doesn't look like there's a check valve. It's super basic. That's fine. And it's got 3/4 inch feed, return, function. Everything's 3/4 inch, and it's really actually pretty super heavy duty and well designed. So you'll have a video of that coming pretty soon here, and that's the next problem that I had. So the fuel, the filter, and then the directional control valve. And then it's just minor things like getting the third axle, getting the safety ring, getting some fenders put on it, and it should pretty much be done. So I've got a bunch more videos coming showing some of the stuff that I've built, like the chute on the back, and the way I mounted the axles, because it's kind of you'll see. It's not my proudest work, but it's what I can afford, and it's going to work well.